I wonder what happens if I fire the ball at 30 degrees. Well, if I do it at 30 degrees, then my V0 square is the same. I don't have to worry about that, I hope. However, I cannot be certain about the angle to better than 1 degree. So you will say, well, come on now. Don't be decadent. I mean, here we had an error of only 0.06% because of this 1 degree, possible 1 degree offset. Let's just ignore this error too. That is risky. That is risky now. Because the sine of 60 degrees, that's what you deal with. The sine of 60 degrees, I think, is 0.866. That's right. But the sine of 58 degrees, which is possible if I'm 1 degree under, is 0.848. And that is substantially lower. And therefore, I must allow for an uncertainty in the sign of the angle by roughly, maybe something like 17 or 18 units. 0.0, what is this difference? 0.018. If you want to check what the sine of 62 degrees is, you will see that that is about this much higher than this. So we must allow for this error. And that is an error which is by no means negligible anymore. There's no point here. That is an error which is 18 divided by 866. That is a 2% error. So now we're dealing all of a sudden with a 2% error in the sine of 2 alpha, even though there's only a 1 degree uncertainty in the angle. And the reason is that a sine curve is like so. So a small angle change here makes no difference, but a small angle change here makes a lot of difference. And that's the reason. And you can see that it is the slope of the sine curve that gives you a much larger error if you are off by a teeny-weeny little bit. So now we're ready to make a prediction. So here comes the prediction. OS, now for 30 degrees. So I have to go through V0 squared, I have that, 60.2. And then I have to multiply by the sine of 2 alpha. That is the sine of 60. Multiply. And then I think I have to divide by g, that is right, 9.8. And I find 5.31 plus or minus. Now, 2% error in the sine of 2 alpha, 5% error in V0 squared. That gives me, I can't help it, a 7% error. So I have a 7% uncertainty multiplied by 0.07. So I cannot trust this any better than 37 centimeters. And so now I'm going to put the markers out at 5 meters and 31 centimeters. This is the 5 meter mark, 31 centimeters. And I allow for 37 centimeters on either side. It's here. And 37 centimeters on this side, that is here. I'm going to set the angle at 30 degrees. Waar kom je? We need woman power here. Stay here, stay out of the fire line, and when that ball hits, you jump on it. Yeah, you jump on it. Okay, everything under control. 5, make sure I marked it right. 5 meters 3-1, that looks about okay. And now I have to change the angle to 30 degrees. Okay, it's as close as I can do it. Okay? You ready? You are? 3, 2, 1. Ah! Hit the jackpot! Incredible. What you can argue now, and successfully, you could say perhaps you have been a little bit too conservative on your errors, and I admit that. But believe me, when I did this morning this 5-6 times, that the error in V0 was quite substantial. The height differences were sometimes 15 centimeters, and so I had no choice. But it looked like we were a bit on the conservative side.